So welcome to our NSX-T Firewall Design and Deployment Best Practices session. My name's Dale Coghlan. Presenting with me today over here, we've got Jennifer Schmidt, and we are both NSX Solution Architects working in the VMware Advanced Customer Engagements team. If you figured out the acronym, it's the ACE team within VMware. We've been working with NSX-T now since about version 1.0, so we've got 2 to 3 years of real-world customer experience deploying and operating NSX-T. And today we want to actually show some of that knowledge that we've gained around operating the distributed firewall for you so that you can go off and hopefully deploy an efficient and scalable firewall infrastructure with NSX-T. Disclaimer, this is the standard slide that they make us put in. Everyone's probably seen it a million times already. This is the agenda. I'm not going to read it out. You can all read. I'm assuming you can all read. But before we jump into things, just a bit of housekeeping. This is a level 300 session, so we do actually expect that you have some knowledge or experience with NSX-T. Okay? We might end up talking about things that you may not grasp the full concepts of, or using a bit of terminology that you might not understand, but just be warned straight up front. We have some links here for some good reading. If you want to go and read up about some of the things we talk about, this is all available for you. Everyone's taking pictures. Do you want me in the picture? Okay. All right. Like I said, the session is being recorded, so you will get access to all the slides as well, and also this recording. So, enough with all the fluffy stuff. Let's jump right in. What are we going to talk about today? We're going to talk about the distributed firewall, some groupings and services, so we'll touch on that, how to do certain policies and rules within the distributed firewall, some operations topics, and also a little bit on scale. What we're not going to talk about is the edge firewall, so the gateway firewall, as it's often referred to, service insertion, or NetX, NSX intelligence, or the NSX distributed IDS IPS feature that was just released. So if this doesn't align to whatever you thought this session was going to be about, I'm not going to hold it against you if you want to actually get up and leave now, but if you do, just give us a good rating on the survey, please. Okay, I'm going to talk a little bit about the architecture of NSX-T, specifically around the firewalling component. And the reason I want to show you this is so that when we start recommending things or certain design decisions are made, you want to understand why they're made from the management and control plane perspective. So prior to 2.4, and everyone should be running at least 2.4 or 2.5 if they are going to be deploying this stuff now, you would deploy an NSX manager, you would deploy an optional policy manager, and 3 NSX controllers. Now, apart from the fact that we've got 5 appliances to run our management and control plane, the blaring thing that was obvious to most customers was a single point of failure with the NSX manager. So the management plane had a single point of failure. In 2.5 and above, we introduced a concept called the unified appliance. This was an appliance where you would actually deploy 3 of them, you would cluster them together, and then those roles that were managed by those separate appliances before have now been collapsed into the unified appliance. So each one of those roles is represented on each one of those appliances and clustered and is now highly available and resilient. So you've got the manager, the policy manager, and also the central control plane with the controllers at the bottom there. Looking a bit into the unified appliance now, you have policy, MP, and CCP. So management plane, central control plane, and policy. Policy is the layer which you generally interact with. It provides the UI and it provides the declarative API or the intent-based system within NSX. It's this intent-based system that you configure your rules and your groups and your firewall sections. From there, it passes it to the management plane, and from there, it actually passes it on to the centralized control plane. The centralized control plane is responsible for figuring out where that configuration needs to be pushed or published to for all the transport nodes. So it doesn't just publish everything to all the transport nodes, it actually does this, what they call a span calculation, and it figures out where that particular piece of configuration needs to be pushed to. It sends that through a message bus system to a component running on every transport node. And a transport node is a host which has been prepared for NSX-T and participates in data path forwarding. So the transport nodes all run an agent or a service as part of what we call the local control plane. So the control plane is split into two components, a centralized component and a local component. The local component here is called an NSX proxy. It receives the configuration from the centralized control plane. We also have an MPA, or a management plane agent. This is responsible for sending information learnt from the transport node back up to the MP. And that's used to feed into the aggregation services on the MP so that they can take aggregated data from all the different transport nodes in your environment and sum it all up and present it to you in either the API or UI. Looking a bit deeper now into the manager itself, we have a reverse proxy. So every interaction that you have with the manager or the unified appliance goes through the reverse proxy. It's the reverse proxy's job to actually figure out, am I going to send you to the UI or am I going to send you to the API? We're going to look at the UI here. When it sends you to the UI, there's two components there, policy and Proton. Policy is obviously the policy intent layer, and Proton is the old manager or management plane component. They both persist their data into the Corfu database, and once they do that, no, actually, sorry, skipped ahead too much. Within Proton, we have our applications that run. These applications, we're only going to show two of them here, and we're going to look at the DFW and groupings. There are more for routing, for different components within NSX, but the two that we're going to focus on are DFW and groupings. The DFW is the one that you interact with and you submit your intent or you submit your configuration to. It takes that configuration, validates that it's correct, validates you have the right rights to use it, and then passes that information off to the centralized control plane once it persists it in the database. There's a groupings application that does the same thing except for grouping objects, so your NS groups, your service groups, and your layer 7 application profiles. So once it passes that information onto the centralized control plane and it publishes out to a transport node, to the NSX proxy, the NSX proxy takes that information, persists it to a local cache, and that local cache is called NestDB. That local cache, NestDB, is installed on every transport node in your environment, whether it's a KVM host, whether it's an ESXi host or a bare metal host. They all have this component on it. And the reason for that is that we want the transport node to have a configuration cached locally so that in the event that the control plane disappears or the host wants to run headless or you're running it in headless mode, or during a reboot, so when the server actually reboots and it comes up, it can read from the local cache. Once the data is persisted into the NestDB, we have a process called the NSX config agent. The config agent is responsible for looking for those updates in NestDB and taking that configuration and programming the data path modules in the kernel. And you'll see it sits above that line there, so it sits in user space. Once we move down into kernel space, we have on the left-hand side over here our vSIP module. vSIP stands for VMware Internetworking Service Insertion Platform, but it's just easier to call it vSIP. It's responsible for the actual DFW implementation in NSX-T. So it does the enforcement, it creates all the rules and all the filters and implements that in the kernel. Up on the right-hand side, the VDPI module is a user space process which does the L7 packet inspection. So that's where our L7 libraries live. And the DV filter user is the construct used to pass the packets when you set the action to punt or redirect. It uses that to take those first couple of packets of a flow, send it to the user world space into the VDPI for classification, and then it actually communicates back to vSIP on what it actually is found in there. The stats exporter. The stats exporter up the top there is used to get rule counts, rule hits, latency information, statistical information out of the kernel modules. So it takes that information from the vSIP module, passes it to our MPA, and we know from earlier the MPA will then send that data back to the management plane, and that's where in the UI you'll see things on the individual rules, how many hit counts you've had on a rule. So it knows about that information across the whole of your environment because each of the transport nodes is sending that information back. The last bit here we've got is a executable that sits on the host, and we're talking about an ESXi host here, which is called vSIP IOCTL. If you've used NSX-V in the past and had to troubleshoot it, you've probably had to look at this command before. The same command exists in NSX-T, and with it you can look at the firewall rules per VNIC, the address sets, the flows, spoof guard information, timeout information, a whole raft of different things. So that is still there today. Who uses NSX-V today? Okay, there's a few of you. And anyone use NSX-T? Wow, there's more T users. That's good. Okay, so when it comes to a packet walk, what actually happens? There is a software construct, which is VMware SFW, and when you look at the data plane, you'll often see a filter being created, and it will say VMware-SFW.2. SFW stands for software firewall, so VMware software firewall. The 2 stands for the second slot on the DV filter. This construct holds multiple tables per VNIC. The 2 we're going to look at here today are the rule table and the connection table. So just like any firewall out there that you have, a physical one, even virtual ones, we have a rule table and we have a connection table per VNIC. So the first time that a packet is received for a flow by the DFW, the first thing it's going to do is go and look for that flow or do a 5-tuple match in the connection table, just like a normal firewall will do. If there is a match, it's going to send it on the fast path and not do a rule lookup. If there's a connection table miss, then it's going to default back to the rule table. So whatever rules are programmed on this particular filter or VNIC, it's actually going to traverse those in a top-down fashion. And obviously, just if there's a match, it'll match. If it denies it, it denies it. This is traditional standard firewalling, except the scope of this is on every VNIC in the environment. And every VNIC has a copy of its own rule table and its own connection table. It's something to be mindful of. Okay. So now we've got that out of the way. Let's talk about some maximums. VMware has been very lax in the past about printing or publishing maximums when it came to NSX. It was pretty much non-existent. Now we have a website called configmax.vmware.com. You can go on there and have a look at the configuration maximums for NSX-T. You need to check this and check this often. Even if you've got 2.5 or 2.4 and you've had it running for 6 months, go back and check this periodically because as the testing teams go through and they ramp up the different scale tests, these numbers might change even within the same version that you're running. I know that because I had to actually go and update this slide from VMworld US to here because some things had changed. So check it often. But this is the one-stop shop to find out all your config maximums. Some of them are soft limits, some of them are hard limits. You can go over the soft limits. Crazy stuff might happen if you do. Crazy stuff might happen if you don't. But if you're actually planning on going over some of these limits, contact your local SE or your account team and get them to vet with the BU on what you're actually trying to do. Okay? All right. Now I'm going to talk about a few of the things that you should be looking at or setting when you're actually starting to use or are using the DFW. So the first one is the session timers. We've all come across applications where we've had to tweak a timer on a physical firewall because of a long-lived connection. An SQL server is a perfect example of this, where they set up a connection, then they don't send any data for a week or something like that. So the distributed firewall allows you to create different profiles that allow you to set different timers. It's composed of 3 components. You create a group to define what you want to apply it to, so the VNix you want to apply this to. The session timer profile, so what you're actually going to set your session timers to, and then a binding map, which actually binds the two together. And here you can see in the UI, you actually go through and you can set your session timers. Set them accordingly to what you need. And you'll see, once you've set them, the values that have changed are highlighted in purple. And over on the right-hand side, once you configure the binding maps, you'll have what they're actually applied to. Now, the gotcha is that you can't actually bind them in the UI today. So to create a binding map, you have to use the API. And I've given an example here. So you create your groups, add your VMs to the group, so your SQL servers, then go and create your profile, and then bind that profile to that group. You can go and validate that the timers are actually made, have been made on the actual data plane itself. So you can jump into a NSX or an NSX prepared ESXi host where that workload is running, run that vcpio-ctl get timeout command, provide it the filter, and you'll be able to see the different session timers and make sure they're applied correctly. What we recommend here is don't go creating snowflakes. Don't go creating a profile for one particular type of app because you're quickly going to end up with lots of profiles. You're going to get a whole lot of sprawl. You're going to have to figure out how to manage these things. Create t-shirt type sizes. Create one for 1 day established timers, 7-day ones, maybe one for 2 weeks. But you just want to try and limit it. And use tags when it comes to group membership. It makes it a lot easier when you see a VM, you just need to make it a part of the DFW 1-day extended timers group, and just tag it with the appropriate tag. It'll get the updated config, and everything will be hunky-dory. That's Australian for okay. All right. DFW thresholds. So if you've worked with V, or if you've worked with T, you understand that we have a finite amount of memory that we allocate to the actual firewalling process. This memory is shared between all the small firewalls on the host, and we also then have to compete with CPU with all the other VMs. So we can actually set thresholds in the DFW. By default, they're set to 90%. And if you're using NSX-V, they're set to 100%, which isn't really very good because by the time you cross it, you're already in trouble. So in NSX-T, they're set to 90%. They're a high watermark. I actually prefer to set them to 80%. It allows for a bit more vMotion in your environment. It allows for host failures. But obviously, you have to look within your environment and see if that would work for you. CPU we can't reserve, memory we can, and we can set these memory limits, but CPU we can't reserve. We are literally cycle stealing with the VMs in the environment. So we want to know when our CPU usage is going up. You can jump onto an ESXi host and run this NSX CLI command, which is get firewall thresholds, and it will show you the CPU usage, which is then that first row, and all the different heaps of memory that we allocate to the DFW. Shows you if an alert is raised, the current threshold setting, current values, how much memory we're actually using for each one of those heaps. And on the right-hand side, it shows you when the alert was last triggered. So if you are having to go back and troubleshoot something, you can go back and go, okay, well, last time we ran out or we crossed this threshold alert was 7 minutes, 19 seconds ago. You can actually go back and correlate. This is something that you can't do in NSX-V, but they've brought it into T. It will also raise some alerts in the logs. Now, we poll every 10 seconds here. So obviously, we don't want to alert every time it goes over, so we do 10 consecutive polls, and if you're over that threshold for 10 consecutive polling periods, then we'll raise an alert. And conversely, if you're under it, you drop under that threshold for 10 polling periods, then we'll actually clear the alert as well. These will end up in your syslogs, so you can alert on them from whatever syslog system you're using. Again, what do we recommend here? By default, it's set to 90, and that's so if you don't know about this thing, you've got some cover, but go off and set it to 80%, and then monitor your environment. You've got to cater for a host failure. You've got to be able to cater for VMs. So you need that headroom. So say a host dies in your environment and somehow another 20 machines end up on this host, you've got to be able to cater for that. So set it to about 80%. You can set the threshold timers per individual host or per cluster, because you create a group and you apply those timers to a group of transport nodes. So if you have a cluster that runs hotter than something else, you can set the limits appropriately. And if you're interested about how much memory actually gets allocated on each hypervisor type or ESXi type, here's the table. I'm not going to talk through it too much, but it's based on how much physical memory you've got in your server. At boot up time, it looks at how much memory and then allocates the heaps accordingly. And it's a quick slide and tells you what all the heaps are actually used for. DFW exclusions. So we have the ability within the distributed firewall to actually exclude workloads from being firewalled. And what that will do if you use the DFW exclusion list is it will not instantiate a filter, that VMware SFW2 concept. It won't actually build that on the VNIC. So if it doesn't exist, it can't be firewalled. You can put VMs into a group, and that group can be then put into the firewall exclusion list. Why would you want to do this? Some apps don't play well when there's a stateful firewall in front of it. Sometimes you just need to disable a firewall or get around the firewall for troubleshooting purposes. Or the best one that I've come across is just because I don't like it. And that one comes from database owners generally. And this just walks through some of the screenshots you'll see and how to actually go and configure the exclusion list. Now, you can jump onto the NSX Manager and actually have a look at what the list comprises of. So this is an NSX CLI command, get firewall exclude list. It'll show you the actual object that's been put into the list. And if you jump onto the actual transport nodes themselves and do the NSX command or NSX CLI command, get firewall exclusion, it will show you the actual VIF, or it's a virtual interface that's being excluded from the actual DFW. So what do we recommend here? The first one is don't go putting everything in the exclusion list. If you've got a mass amount of VMs or workloads that you want to exclude from the distributed firewall, and it's the majority of your environment, maybe you need to consider actually disabling the firewall in your environment, or writing the rule set in such a way that it only enforces on the subset of machines that you got. The exclusion list isn't meant to be a mass exclusion. It can take a lot, but it's not really designed to it. The group that you use, again, use tags for the membership criteria for the group so that you can simply tag a VM that needs to be excluded from the environment and it will automatically pick up the exclusion and have the firewall removed. The drafts feature. Has anyone used the drafts feature in V or T? Okay, good. We have the capability to take an automatic or a manually created DFW draft. The reason that this happens is so that if you make a firewall change and you need to roll it back, you can roll back. What will happen is that the firewall will automatically take a full config snapshot every time that you publish to it. And you can see we've got this timeline here. You can actually go back in time, have a look who created the draft, whether it was a user-created one, whether it was an auto-saved one, whether it was saved by someone else. You can go then load those and have a look at what they were. And it will actually tell you how and which rules are actually changed. So on the bottom right-hand side there, it will give you a traffic light system. A red means it was deleted, green means it was added, yellow or orange means that something changed. Admittedly, it doesn't tell you what changed. It just tells you that something in that rule changed. Now, the thing to be mindful of here is this is a complete config at that point in time. So often what we hear customers wanting to do is go, I want to take a snapshot today, I want to make some changes to it, and I want to publish it in 2 days' time, or whenever my change window is. That will work. You just have to be mindful that if someone else makes a change to the live system between now and when you go to publish this draft. When you publish this draft, it won't have their changes in it. So you will overwrite their changes. So just remember, it's a full snapshot at the point in time it was taken. We've seen people get into situations where they've had multiple changes made after that snapshot was taken, then they've gone and applied this after it, and it's removed everything that was made after then. So yeah, just be mindful of that. Identity Firewall. Does anyone use Identity Firewall here? Good. I'm going to show you some things here, and surprisingly, all these best practices are actually published in the official documentation. So I'll just run through them quickly. We only support, in the source of a rule, TCP-based connections. There's a technical reason for that, and it's the agent that runs in within the actual virtual machines only currently looks at TCP traffic to initiate the connection, which then forwards that information through a channel to the hypervisor, which then can enforce actual traffic. So don't go mixing UDP and TCP traffic in a single rule. Don't go mixing different sources in an actual rule. So if you're using an identity firewall rule, you only want to use a group that is an identity-based group in the source of the rule. You don't want to add another group that is just static VMs in there, because weird stuff's going to happen. And it won't actually work the way you think it will work. Who runs Windows 2008 here with an Active Directory? One. Did someone else just go like that and then put their hand down? It's what? It's at least 10 years old now. We don't support it. There's a fair few customers that still run it out there and expect it to be supported, but come on, guys, it's 10 years old. If you use custom ports because you like to change the ports of things because it makes you feel like it's more secure, then it's not actually going to work with NSX-T when you try to point it as an LDAP source. So we don't support custom ports on LDAP. Selective enablement. In the UI of NSX-T, in the firewall section, there's a banner that comes up across the top and it says, you have not got identity firewall enabled. Do you want to enable it? People want to get rid of that banner. So they click enable and they turn it on. The problem with that is that it actually uses resources. And so they're now consuming resources just to get rid of a banner across the top of their screen. So don't go enabling it just to get rid of that banner or just because it annoys you. And when you do enable it, you have the option of doing it on a per cluster basis. So only enable it where you need it. It does consume a tiny amount of resources. And if you've got a massive AD, don't go just pointing it at the base DN and say, oh, give me everything. Because like I said before, we have limits and we publish those limits. And if it tries to suck down 2.5 million objects, what are you going to do when you've got 2.5 million objects and you're trying to suck down and synchronize? It's going to have a hard time. And you'll see here, these are all the limits that we actually support. Identity firewall, Active Directory groups in the middle, and total users in all Active Directory domains. Keep an eye on those two figures because they're the ones that will catch you out if you actually go and do this. And now I'm going to hand over to Jen. And she's going to give us some insight onto building a performant rule set.
So building a performant rule set. This is a very important and interesting topic, so hopefully you guys will pay attention. So our team has seen a lot of issues and escalations raised throughout our time here, and a lot of it has to do with how rule set was built, whether it be a latency problem or their distributed firewall just kind of blows everything up. But hopefully we'll be able to give you some good best practices here so that you don't fall into that category. So have a globe here, and let's imagine I'm an administrator and I manage firewalls across the entire globe. And I want to protect a rule set workload between, let's say, the US and Africa here. And with these traditional physical firewalls, if I want to protect VM app going from the US to Africa, where would I put those firewall rules? So I wouldn't go and put that rule on, let's say, the South America or the Australia firewall. Now, would I? Of course not. That would be silly. You know, if we're putting on all these other rules, the firewalls here, you know, you're just taking up latency and CPU and all of that of a firewall that workload would never pass through. So let's take that same theory now to the hypervisor level. I've got a bunch of VMs, and each VM and VNIC has its own firewall. Let's say I want to protect a workload between these two VMs here. Now, by default, if you configure a rule in the firewall, it will put the distributed firewall your rule would get put into the distributed firewall category, meaning that every rule will have, every VM and VNIC will have that rule applied to it. But same thing with the physical firewall. If we are only communicating between these two VMs here, why would we put that rule on all of those other VMs? You know, as Dell's already said, we're going to have high latency or, you know, use CPU and memory processing these rules. So what we want to do is we want to limit the scope of that firewall rule to the source and destination VMs. You know, if you have a small environment, you may not see too many issues around this, but once you start getting to larger environments or big rule sets, you can really start to see an impact. And, you know, that's when you start calling us, and as much as we would love to hear from you, we really don't want to in that way. So what is our recommendation? And how do we create these efficient rule sets? So the number one rule that we have for everybody in here is use the applied to field. That really is the number one rule that we need to do here. So using the applied to field, we'd be able to limit the scope of the firewall rule sets to only the source and destination. So that way, you know, you're not creating a long list of rules for a VM or individual VNIC that, you know, that packet is never going to match on. You really want to try to consider this a mandatory option and not say, oh, I'm not going to go and configure the applied to field. It's no big deal. Definitely take that into consideration. So we have a lot of customers too that have just IP sets in their rule base, and you know, you can't limit the source and destination on an IP set, but what we can do is say limit the applied to field to a segment or a logical switch that those IPs are a part of. That way you're still getting some kind of scope around that, that firewall rule, and it's not just being applied everywhere in your environment. So, no excuses. So, applied to. If you haven't seen it before, it is the last option there on the individual rule basis. So in NSX-T, this can be applied to a group level and the individual rule level. So in that first section here, we have it applied to the group level. Anything applied to the applied to in the group level is taking precedence over anything in the individual rule level. So you can't see what it's applied to here, but you'll see it says applied to one group. So that group is scoped out to VMworld prod DB and VMworld prod 2 DB. So that means that in that section, those firewall rules are only going on to the VNICs of the VMs in those specific rules. Now in the bottom section, the applied to, it will always say distributed firewall if it's not actually applied to a section level. And here's where we'll apply it to a actual rule. So we have a good rule, VMworld prod DB and VMworld prod 2 DB. And in the applied to field, you'll see there that we have both groups in the applied to section, meaning it's also limiting the scope at the rule level. But in our bad rule, you'll see our distributed firewall is set to DFW, as well in the section level. Now, every single VM and VNIC in the environment has received that rule, whether it needs it or not. So in the API, you can go and pull these calls up here, and you can see where the applied to is. In the API, the applied to is actually called scope. So if you're using the API, just make sure that you're setting the scope. So you'll see here for our good rule, the scope is set to the path where the VMworld prod DB and prod2 DB groups live. And then also on the bad rule, you'll see that scope is any. So that is in turn meaning that it's on the distributed firewall and being applied to all of the VMs and VNets. And here's another API example, and this is just for the section level based. So you'll see here on our section, the top was where our section was, had the applied to, and that is set to our VMworld prod DB group. And then below that is the section where we had any for the distributed firewall again. So that whole section is distributed firewall, and then that's where you'd want to limit the scope on your individual rules. So rule ordering. So there are definitely some times where the order of your rules will impact your environment greatly. So it's definitely important to consider how your rules are ordered. Luckily with NSX-T, we've introduced the concept of categories. And the categories are there to kind of help be a template of how to order some of your rules. And a category essentially is just a grouping of rules. And within those categories, you can have sections, and then within the sections, you can have your individual rules, and everything gets kind of layered in that way. And everything reads from a top-down approach here. So I'll start with your Ethernet rules, your emergency rules, and then all the way down to your application rules. So when you order your rules, you want to make sure that your most hit rules are at the top. Right here is an example of the UI of all of the rules, and in the UI, it's really just a consolidated list of all of your firewall rules. It doesn't mean that a particular VM may have all of these rules on it and in this order. So in NSX-T, I know in V, I know some of you guys said you're running V. So in V, if you wanted to look at the rules on a particular VM, you had to go into the CLI, run a bunch of commands, find an object, go and, search on that object, and you had to just keep going down. But in T, we're able to do it a little easier if you want to see what rules are actually applied to a VM. It's in the Advanced tab, and if you click on go to Virtual Machines, here we have VMworld DB2, and then on the right over there, you'll see the logical port. Click on that logical port. So this brings us to the logical port screen, and we'll go to related and then firewall rules. And here you see a list of the firewall rules that are specifically applied to this VM and that VNIC on this VM. So it also shows a bunch of the rule IDs, and like I said, they're ordered here for this particular VM. Now, in order to order your rules properly, you can use that list to see what rules are applied to that VM. And then you can use the vsip command here and see, okay, what rules are being hit? In this example here, we have rule 2052. Now, that has about 26 evaluations and hits. And then you'll see above it, there's about 6 or 7 rules that have never been hit. So that's a waste of CPU and memory. In this example, maybe not so much, but imagine you had a rule set of, say, 100 rules there, or 1,000 rules for this VM, and all of those are, have minor hits or no hits. You'll want to take the rule that has the most and kind of move it to the top. So you want to move it to above rule 2062 there. Now, when we say let's move that rule to the top, I don't mean the top of that UI, the consolidated list. You want to use the tools that I just showed you here and then move that rule to the top of the rule set for that particular VM. So whether that's section-based or, individual rule levels, you can kind of see where those rule IDs are and then place it in the correct numbered order. This is especially important in high latency environments and environments with a high churn because, as I mentioned before, the CPU and the memory, it just starts getting hit, and you really don't want to cause these issues in your environment. So stateless rules. We have the ability to create stateless rules in our environment, and a stateless rule is a rule that, as the packets flow, it's not leaving a connection in that connection table. So every time a packet is going for a stateless rule, it has to hit that rule set every single time. So when you're creating the stateless rules, you definitely want to make sure that they are at the top of the entire, not the entire list, but towards the top of your entire rule base. Otherwise, that packet for the stateless rule is going to hit every stateful firewall rule, knowing that it's never going to hit on one of those or match on one of those. And then, again, waste memory, waste resources in order to get to where it needs to go. Now, you really want to try to limit stateless rules as much as possible, but if you really do need them, follow these practices. And another thing on stateless rules, they can only be configured at a section level, and it has to be created at the time the section is created. So you go into the settings of that section, and usually that stateful toggle is set to yes and green. You just want to move that over to no, and you'll be able to configure it that way. Rule explosion via services. So when it comes to firewalling, you all know that in general, you need to match on a source, destination, port, and protocol. And when these rules get pushed down to the data plane, if you have multiple services within a firewall rule, those kind of get extrapolated out into maybe more than one rule. This is kind of a big one. I myself have been guilty in the early days of creating rule sets with a lot of ports and protocols in them and then not realizing what was happening until I knew what was happening. But we have a rule here, and it's called web access. And in that rule, we have a service called VMworld Web. And that service is created from two separate service entries. So we have HTTPS and HTTP. So here it shows us having one rule. Now, if we go into the data plane here, run this get firewall command, you'll see that this rule actually is two rules. We have one single rule for port 80 and another single rule for port 443. Okay, no big deal. Port 80, port 443, it's only two rules. But now let's say you have 100 rules, and they all have multiple services in them. They have services like Active Directory, where you have 10 plus services in that group. Now how many firewall rules do you have? 2, 3 times more than you thought you actually had. So in order to mitigate this, what we want to do is create a service entry with multiple ports within one service entry. So here, in this example, we would make a service entry, call it TCP, service type TCP, and put 443 and 80 on the same line. And you can see here now, once it's pushed down to the data plane, it's only one rule, 80 and 443 on the same line. So when you create these service entries, you can have up to 15 ports, and then a range would count as 2. So, if you had 7 ranges and 1 port, that would equal 15 there. Also, these service types can't be combined into one service entry, so if you did have UDP rules in this, you would have to create a separate UDP entry, and that would be broken out, but that's pretty typical anyway. All right, I'm going to hand it back to Dale. Thanks.
Cool. All right, thanks, Jen. Who here has ever wanted to migrate to NSX and just bring across their firewall config from their physical firewalls. Bad, 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 bad. Don't do it. If you want to do it, and you're insistent on wanting to do it, there are a couple of things that you need to keep in mind. I can guarantee you, if you go down the path of just pulling your config in a one-to-one relationship, just literally do it, you will hit memory problems, you will hit CPU problems. I can guarantee you this. And what is it that's such an issue here? If you look at this picture, we've got, everyone should know this is a Tesla, and what's sitting in the engine bay there? It's a nice big V8, it's an LS1 actually. And yes, this might work. The same way that migrating your physical firewall config into NSX-T or NSX in general might work. It was never designed to work around those types of constructs and configurations. This might work. It's not going to be as fast as what a Tesla is. It's going to work in a different way because you have to fill it up with petrol now. But it will work, but it's not going to be optimized. It's not going to be used the way it was meant to be used. Same thing happens with migrating firewall configs. If you migrate in from another vendor's firewall, generally that rule base has been designed and optimized to work on their firewall implementation. Once you bring it across, it doesn't really play that well. It'll still work, but you now remember we're in a distributed firewall system here. It's not one central box that everything has to go through anymore. There we go. So if you must go ahead and do this, what are we going to tell you to do? For every IP address that is a /32 or a host address, if you can match it to a VM object or a VNIC, replace it with that as part of your importing process. You'll need to figure this out as you do it, because every firewall is different. But if you find them, replace them with the objects. If you find networks within your physical firewall config in groups and rules and things like that, substitute them for a logical switch or a segment if one exists, because that's essentially what you want, everything on that network. And like Jen said, map multiple ports into a specific service entry. Because what will happen is if you take like a checkpoint group object, it'll have multiple services configured in there. And the thing that most people want to do is just do a one-to-one, copy that group over, copy those individual services across because they reuse them in other ones, and then they're going to end up with rule explosions. So the 100 rules that you think you migrated ends up being 1,000 rules on the data plane for that VM. And this starts to get a bit of an issue when you get more and more rules. And the biggest one that you must adhere to is using the applied to field. So the physical firewall only has a single box that every rule is applied to. When we get to our distributed system, there's no point having 5,000 rules from that physical firewall on every VM in the environment. Limit the applied to where the rule actually goes to. You may be able to do this through a script or through whatever process you're importing with. You may have to sit there and do it manually, but I guarantee you if you at least use the applied to, you'll be in a better spot once you actually start bringing in more rules and more workloads. So what are the key things we want you to go away from this session thinking about? Have a basic understanding of how the distributed firewall works, the management plane, control plane, the unified appliance, how rules are enforced, and the fact that every VM has an individual firewall sitting in front of it. How to leverage the applied to field and why it's so important in working with the distributed firewall. Understand how your rules are actually applied on the data path. So how they look different from the UI. So when you're actually creating rules, you're understanding the impact that you're having on the data plane. And also how to validate your rules on the data plane. So how do you look at what rules are applied to a particular VM and how you can actually then go off and run commands to see what they look like on the data plane itself. And just remember that one, because that's the biggest thing that we can actually tell you to do, is use the applied to field. That's it for today. Does anyone have any questions? And if you do, we're going to have people walking around with mics. Oh, we've got a question over here.
So just a question on the, not for what's in now, but maybe a future solution. So that applied like the order of precedence of the rules, where you've got some with no hits, some with some hits. Is that going to be automated? Because that seems like a very good candidate that if you're feeding those statistics back up, that it could be done automatically if you would desire it.
Yeah, so I'm going to be very careful about the way I answer this. Because your source and destination of the rule, so the basic theory is anything that you put in the source and destination of a rule is essentially what's going to be in the applied to list. The catch to that is that the applied to list is generally just a object of VNICs, or a list of VNICs that the rules need to be applied to. So if your groups are written with just IP addresses in them, and you use those groups in the applied to field, you've got nothing to apply the rule to, because the rule, or those groups, are just IP addresses. There's nothing to map them back to a VNIC. The follow-on question that we normally get from that is, can't you tell me which VNIC my IP address maps to? Which is a valid question, and we do have that information, except we can run overlapping IP address spaces. So we don't know the context of if you're running a VM and you're running a VM with the same IP address, and someone's written a rule with that IP address, which one do we apply it to? We have no context over that. So yes, everyone's asked the question before, and that is the response to it.
Thank you.
No worries. Oh, no other questions? All right, well, thank you very much for your time, everyone. If you could fill out the surveys, that would be greatly appreciated. Yeah, I can pay you if you want. Some good feedback is always good.